Hey guys, welcome to Great Learning. Chatbots have become super popular today. You can do everything from ordering groceries to getting yourself a new car just by having a conversation with a bot. Now it's important that you understand that even you can build simple chatbots and put them to use effectively. Since Python offers fantastic syntax capabilities, it definitely should be the programming language of your choice for this application. But at the same time, it becomes super important that you understand everything there is to know about chatbots theoretically and then use that learning to check out and understand practical demonstrations and case studies. And this is exactly what we're going to do in this session. Well, excited? Let's get started. Before we get started, I want to introduce you to Great Learning Academy. This is a free initiative by Great Learning where you can have access to over 200 plus courses with 1000 plus hours of free content on all of the trending high demand domains absolutely free. Register now to complete the course and get your free certificate of completion as well. Check out the link in the description box of the video below for more details. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell. This is done to make sure you do not miss out on any of the new updates or video releases from Great Learning. And of course, guys, if you enjoy this video, show us some love and do like this video. Knowledge increases by sharing, right? So make sure you share this video with your friends, colleagues, and everyone who can make use of it. And at the end of it, make sure to comment on the video if you have any queries or any suggestions, and I'll be more than happy to respond to all of your comments. Alright guys, coming to the agenda of this particular session, build your own chatbot using Python, we are going to start out by taking an introduction to chatbots. We need to first of all understand what chatbots are, how they work, and I guarantee you that all of you all have used chatbots, right? Perfect. After that, we're going to dive right into the heart of the concept and we're going to take a look at the various types of chatbots that we have out there. Now for our usage purposes, we do have some types, and of course in its working itself, there are some divisions as well. So we are going to have to take a look at all of these things, right? Okay. After this, we're going to take a look at the top applications of chatbots. There are so many applications around us, right? So we're going to discuss some of the ones which definitely deserve a noteworthy mention, right? Now, after that, we're going to take a look at the architecture of chatbots. Now, the architecture of chatbots basically talks about how the entire thing works. What are the components that are required for a chatbot to work? How are they laid out together? And the most important thing is how they work hand in hand together to solve the problem, right? So that is what we're going to take a look at when we are discussing, the architecture of chatbots. After this, we definitely need to understand, once we know the architecture, we'll be very curious to sort of walk through and run through the process in a step-by-step manner to understand how a chatbot even sort of, recognizes what the user types in or the user says and how it responds back with a valid response, right? So we need to check that out. And after that, at the end of this particular session, we are going to actually practically take a look at, building a simple chatbot. And in fact, I'll be walking you through the code of, what it takes to build a very simple chatbot. And it really isn't as difficult as you might think at this moment of time. So make sure you guys watch till the end of this particular video to have a complete understanding, right? It's very important to have practical learning always complement your theoretical learning. Alright, perfect, ladies and gentlemen, let's get started with a quick did you know about Python, right? Now, Python is a fantastic programming language. It should really not come as any doubt to you that it is one of the most, one of the most sought after programming language today, right? It is in fact considered as the world's #1 programming language today. Now, there are many reasons for that. You can talk about any domain, be it data science, be it artificial intelligence, be it, in terms of data analysis, be it web development, be it game development, user experience development. So you can talk about these wide array of domains where Python might not have a direct footing, right? Yet Python is the programming language that again powers through all those domains as well. That's one of the reasons why, it's considered as a very, very popular programming language today. That, and of course, millions and millions of people use Python today.
Perfect. Now, since you guys are watching this on YouTube, if you're watching this on your browser, you might have watched certain TV shows on Netflix, platforms like Amazon Prime, Z5, Hotstar, and all of these things, right? So if you've ever used that, did you know that all of these actually work with Python in the backend? Even though directly you're not seeing Python code, that's because of user experience, but in the backend, right? If you're using, for example, a Firefox browser, Mozilla Firefox, it uses somewhere around 230,000 lines of code that are absolutely written in Python, and that is what gives the functionality, and that is what makes Firefox work, right? Similarly, YouTube uses a little bit of Python, Netflix uses a ton of Python. In fact, Prime, Hotstar, all of these guys, wherever they're trying to use recommendation systems, wherever they're trying to push a product across, they definitely are using Python, because it offers a ton of benefits for a lot less time that you have to invest in it, right? Okay. Now, one fascinating thing about Python that I always get asked is, why did the inventor of Python name it after the snake? Well, we know the snake, right? Python is a type of a snake. It's a venomous snake. So basically, the founder or the inventor of Python, Guido van Rossum, was a person who was, a very big fan of a famous TV show called as Monty's Python Circus, Monty's Flying Python Circus, or on the likes of that, right? So basically, as this, it was basically a comedy sitcom type TV show, is what I've heard. Of course, I haven't watched the TV show. This was way back, at least 50 years ago. So when you take a look at it, Guido van Rossum actually wanted to pay tribute back to the TV show that he loved so much, and that's the reason why he named his programming language after the TV show, Monty's Flying Python Circus, right? Monty's Python Circus is the reason why you see Python as the name of this programming language. How fantastic is that, right? Now, quickly, let us discuss the third point that's seen on your screen. In fact, did you know that, for the domain of natural language processing, or NLP as it's called, Python is extremely popular there, right? Now, when we talk about NLP, I'm sure that if you've clicked on this video and if you're willing to build your own chatbot, you might know a little bit about NLP, right? Natural language processing is basically how the machines understand everything that goes on, when we converse or when we talk in a natural language, right? Be it English language or any other language. Now, if you take a look at it, chatbots entirely depend on natural language processing, right? It's not like I'm telling out zeros and ones in terms of instructions and the machine is sort of figuring that out. No, I'm whenever I say, hey Google, what's the weather like tomorrow, I am basically using English language. I'm using a natural language, a language which is basically natural to me, of course, right? Now the computer has to understand all of that, and it has to give me valid answers after understanding the language, the question, and everything that the question asks for as well. So this is another reason why Python is considered, because again, it has multiple libraries here that will give you uninterrupted access to some of the most amazing functions that you can use to build your chatbots in a really easy manner, right? So I hope this quick did you know, helps you get aligned with what we are about to learn in today's session, right? Perfect. Now, let us quickly get started by taking an introduction to understand what chatbots are, right? Now, what are chatbots? I just actually gave you an example in the previous slide when we were discussing the did you know, right? So whenever we think about chatbots, in fact, in the previous slide, I already gave you the name of a chatbot, right? Now, think about Siri, think about Alexa, think about Google Now, think about, there's a lot of chatbots out there governing today's world. And in fact, you might not even notice that you're talking to a chatbot in real life, right? Now, before we come to that, let me discuss what chatbots are. Now, chatbots are basically we're trying to simulate human beings on the other side of our display, where we're trying to get our machine to understand, process, and give us vital answers and perform specific tasks by understanding human languages. Now, this is the most fascinating concept that in fact, I think this was long back. We're going to discuss about the history of chatbots, but you have to understand that this has been a concept for 100 years, and right right now you can see the extent at which chatbots are having an impact around us, right? It's very simple. The first chatbot, came out. It was created by this person called as Joseph Weizenbaum in the year 1966. This chatbot was named Elisa, and in fact, Elisa is still active. There are certain websites where if you just type in Elisa in Google and just type Elisa chatbot, there are websites where you can actually practically talk to Elisa and sort of see how it was way back in the late 60s, right? That's a very fun thing that you guys can do. Now, an interesting thing about chatbots that you have to understand is that it is not just a simple transaction where I say hi to a chatbot, the chatbot says hello back, and we are done, right? It has been so sophisticated in today's world that chatbots now can so they have the capabilities. Whenever you're talking to a chatbot, right, you will not know that that's a chatbot. That is how good things have got now. They have become so human in a way in their conversation that we have the capability to judge either it's a chatbot or if it's a human, and sometimes even the best of the best are fooled into thinking a chatbot is actually a human being on the other side. How fantastic is that? Right now we are making our computers intelligent enough so that they are discernible whenever you compare it to a human being, and that again as a pathway to achieving artificial intelligence and of course opening up 100 doors for the future is definitely something the world of chatbots is contributing into, right? But then, okay, so we know what chatbots are. We know a little bit about them. We have used them in terms of Siri, Alexa, Google now, and all of that. But then, what are we talking about when we, talk about history? First of all, we saw Alexa that came out in 1966, right? But then, even before the first chatbot ever was created, there was this fantastic mathematician called as Alan Turing. He was, in fact, he had a very strong, impact on how the course of the Second World War in fact happened, right? So again, that's another story of its own, and in fact there's a movie based on Alan Turing as well. I think it's called The Imitation Game or something like that. You guys definitely should watch that. So basically what Alan Turing did, he asked a question saying, can machines think like humans? If they can think like humans, do we get to know that that either we're conversing with a human or a machine, right? Now that led to a test called as the Turing test. A Turing test is basically a test where a human is on one side and there's a computer on the other, but the person doesn't know that there's a computer. So as and when he asks certain questions, as and when the human asks questions, if the computer is able to provide answers to a degree where the person doesn't know that it's a machine doing it, but rather he or she thinks that it's a human doing, that is when that machine passes the Turing test. As in that machine was intelligent enough to fool the human being sitting there into thinking that into tricking the person, basically knowing that hey, this person actually was talking to a machine and not another human being, right? So that is when people were thinking about how best can you make your machines think in terms of align its thinking in terms of human beings. So at the end of the day, whenever you're talking to a chatbot or whenever you are talking to an entity that has passed the Turing test, of course it's very simple to pass the Turing test now for computers and machine learning algorithms, but back in the day when you had something that passes the test, that is when things really got exciting, because that was when people started realizing that you can bring together a whole world of technology that never existed, right? Now, for example, I'll tell you this amazing application. This is done by the people at Google, right? Now, they have a chatbot which has the capability to call a restaurant and book a table. Maybe you want to go out to dinner with your better half, with your wife, family, whatever it is, right? You can say, hey, Google, book my reservation for that hotel at that particular time on that day. And boom, it's not like it'll remind you to do it yourself. Google will actually call up the restaurant, talk to the manager, make a booking, ensure that the booking is done, and in fact it'll even remind you later saying, hey, I had booked this for you, you have this. How fantastic is that, right? They actually did a demo. The people at Google did a demo on this, and it orders food and it books restaurant tables, and you never know that you're talking to what could be basically a simple piece of code on the other side, right? That is how fascinating the world of chatbots has been, and it's just that we are at the stepping stone where we are still looking towards how best can we apply them and use them. Right now, this is a domain which, again, in the world of chatbots, is basically evolving in a very rapid manner. As you can see, there was a time when you could just say, "Hey Siri, tell me what the time is. Hey Siri, set my calendar," and all of that. Right now, you can do whatever you want. You can ask Siri to guess whatever song is playing in the background. You can take an image, you can click an image and send it to Siri, and Siri, Google, Alexa, you can ask it to sort of take a look at the image and think, tell you about what it thinks of the image. And like, guys, the amount we can just go on and talk about these applications and how best the domain is improving, but at this moment of time, I think it's clear for all of you all that it is super important to analyze that the growth that is being shown in the chatbot domain, and of course the number of applications itself for the future, that should give you a positive trend, and that should give you a fantastic trend in case if you guys are very serious about, in fact, maybe building a career around chatbots in Python, right? All right, perfect. Now let's quickly take a look at the history of chatbots, and let's try everything, try to line everything up down from the 60s to the latest standards, right? As we saw, Eliza came out in the year 1966. Then we had another chatbot called as Parry in the year 1972. We had Alice in 95, and we had Smarter Child in 2001. Now there's a good chance you might have not heard of the first four, but there's a very good chance you might have heard of the next three, right? Siri, Apple's chatbot, came out in the year 2010. Google Now came out in 2012, and Alexa came out in 2015. Now if you take a look at it, I've been using Siri since the day one, ever since Siri came out, from 2010 till today. It's been what? It's been 11 years, and it's an absolutely fantastic ride of how they developed this particular platform. And of course, the person who voices Siri is also very famous. Her name is Susan Bennett, the US female version of Siri. Now they have multiple people voicing these chatbots. It's not like you get a robotic artificial voice when you talk to the chatbots now. It's literally a human voice on the other side, right? That is again a fantastic process of how they get it done. Now it's not like a human will say all the words that are present in the dictionary and then a chatbot is built. They pick up certain syllables, certain words, and that's how they get the human being to record the voice for the chatbots. It's again a very interesting process we can discuss some other time, right? Perfect. Now that we've understood this quick introduction, now that we know a lot about Python, now that we know about the history of chatbots, it becomes super important that we talk about the various types of chatbots that we have today, right? Now, the chatbots is basically a concept where you can sort of divide it into multiple different things. You can have 5-6 different types of divisions, and it can get confusing and a little complex. To keep it really, really simple for to keep the entire scope of audience in mind, we've sort of given you two very, very important types of chatbots that every other chatbot is based on, right? So we have text-based chatbots and voice-based chatbots. Now, the chatbots that you might have used in terms of Siri, Alexa, Google, they are both text and voice based chatbots, right? So you can either talk to them or you can even text with your keyboard open, right? So maybe you've seen this. They're all text based chatbots as of how they work. Whenever you try to say something, the message is actually printed again on the text, and the text is what is understood by the chatbot, right? But then of course, there are many chatbots where it will only recognize whatever you say, as in it knows how to recognize voice, it knows how to understand who is talking, what is being spoken, what is asked of it, and what's needed to what's to be provided, right? So this is text based and voice based chatbots. Now if you are aligned with maybe in the shopping in the online world a lot, you will come across these chatbots a lot, be it either you're ordering food on Swiggy or Zomato, or you're talking to you're chatting with an Amazon customer support portal thing, right? So there again, at the start, 99% of the time you will always be talking to a chatbot. In fact, some of these applications will even tell you that you're talking to a bot right now, and it will help you with everything that might solve your problem. Right now there are things which might not solve your problem. If the chatbot runs out of options, it will not say sorry, I cannot help you. It will tell you, hey, can I connect you to a human representative so that you can have their help for this particular query, right? So it's a very well-rounded world where there is no jagged edges no matter what sort of questions you ask, a chatbot, a very well-rounded text or even a voice-based chatbot has the capability to give you well-rounded answers on that. The text-based chatbot will give you a textual output, while the voice-based chatbot, of course, as the name suggests, will sort of read out the answer to you or read out whatever it is that you asked of it, right? So these are the important types of chatbots. But then when you're thinking about designing a chatbot, this is where you have to again sort of split it into two more types of chatbots, what we call as the rule-based chatbots, and of course we have the self-learning chatbot. Now if you take a look at rule-based chatbots, as the name itself suggests, rule-based, right? So it has certain rules that it has to follow to answer all the questions that is asked by the user. So every answer that it will sort of give you to your questions is already available in a group of details, or let's say it's basically called as rules. So it uses those rules, and these rules are defined by the user himself or herself, that way that this chatbot can use all the data that's present there and sort of give you simple to even pretty complex answers, right? So if you have a ton of rules and if you just provide it a lot of information, well, at the same time your chatbot becomes super intelligent on its own, right? Correct. Next, you have something called as a self-learning chatbot. Now, self-learning chatbot is an even better game to play because self-learning chatbots are mostly based on machine learning models, right? So they're basically created using machine learning algorithms. So this is a bot which will have the capability to communicate, to learn new things, to understand new things by using the power of machine learning. It will use it to learn new things, assess what's happening, what's required from it, and give you the answer to the question that you are asking, right? So it's a fantastic thing when you take a look at the other side of it. Now, when you talk to a non-technical person to talk about the types of chatbots, you'll probably talk about textual based and voice based chatbots. But now, since you are on the verge of creating your own chatbot, you definitely need to understand two more divisions out here, which is basically the rule based chatbot and of course the self-learning chatbot. Both of them are super popular. Both of them have their own advantages and disadvantages, and they have their own niche applications, right? Now, as soon as you look at it, you might be like, hey, a self-learning chatbots looks more fascinating and looks more sophisticated just because it uses machine learning. So is it more powerful? In some cases, yes, it is more powerful. The self-learning chatbot is more powerful, but that does not mean that for all the cases it will work fine, right? So for some places, like you will need to understand that there is you need to understand first of all that rule-based chatbots also are fantastic. They're super efficient, and if you provide a good amount of data, there is no beating the efficiency of rule-based chatbots, right? So again, these are two other types of chatbots that I wanted to discuss with you now that we are involved in the process of building one, right? Perfect. Now that we understood, we had an introduction, we looked at the history, we also understood, how these chatbots work, the types of chatbots and everything. Now we've come to a point where we can go ahead and discuss some of the top applications of chatbots, right? Now, when you are usually taking a look at top applications of chatbots, well, in fact, when I was researching for this video a couple of weeks ago, you definitely have to think about an important thing. Every application I looked at when I was, taking a look at chatbot was every application was fascinating. It really is very difficult to say, hey, these are the top applications, because I have found use for everything that you see on your screen right now. In fact, if you're a person who has used the concept of smart homes, smart lighting, and all of that, you will definitely understand that, hey, you can literally do whatever it is that you want by bringing together the world of chatbots and Internet of Things, IoT, right? And most of the chatbot application is basically that they have a smart IoT device which also works with a couple of your chatbots. That is what makes the entire thing to be smart, right? Now, anyway, coming back to the top applications of chatbots, first of all, yes, there's hundreds if not thousands of applications that we have today. But again, these are some of the things, the applications that we're going to discuss are some of the things that you might have already used, right? Now take a look at the first one. It says help desk assistant. As I mentioned, maybe your food was running running late on Swiggy or Zomato, maybe your order was running late on Amazon or something like that, you usually talk to a representative, right? You usually open a chat portal, there it'll ask all the details for it. It usually asks the same questions in a form of a template. Whenever you have an issue, you have to pick from multiple options, and it'll try to see if the chatbot itself can solve your problem. But then yes, there is only so much that the chatbot has in terms of functionality. So if it cannot solve your problem at the help desk assistant, it will basically raise the ticket so that a human representative, an expert on the other side, can connect with you and help you out with your problem, right? So that's one type of chatbots. Then we have the email distributor. Now email distributors are absolutely fantastic if you're a person who likes to keep your emails very structured and make sure that they're labeled, they're ordered in a nice way. There again, we have multiple chatbots working. Now these are the newest applications, but we do have some of the classic applications where, think about spam filtering, right? Spam filtering is again something which is very much required, because you require a chatbot to read through the mail that has been sent to your inbox and then make an assessment, say, hey, this is an important mail, this is a junk mail, spam mail, this has a virus, whatnot, right? So that part of the thing with respect to chatbots is also taken care of. And then take a look at home assistants. Home assistants are absolutely fantastic, right? So I have this vacuum cleaner called as Roomba. Roomba basically is like a robot vacuum cleaner which just goes around the house and cleans your house, and eventually it will know where all the walls are, where the unclean spots are. It will go clean it. Eventually it will just dock by all on its own. You might have seen videos on Instagram where there are cats or dogs which are riding on this tiny robot which is the vacuum cleaner, right? So again, those are very intelligent, appliances, or let's say home assistant entities, where you can actually have a lot of programming in them, add a lot of functionality, and use them to their fullest. Right now, you do have something called as home automation, which is extremely popular these days. So let's say if you have a theater at your home, all you have to do is you have to open the door and say, "Hey Google" or "Hey Siri," turn on the home theater. Right? So it's going to turn on the air conditioner, turn on your projector, turn on your speakers, turn on your computer. It's going to turn on so many things, and it's going to ensure at the end of the day that while you walk in to your theater, right, the temperature is also taken care of, the lighting is taken care of, there's music playing in the background. So it just gives you an entire well-rounded feeling, is what I want to say, right? The home assistants, there's various types of home assistants again. And then we have something called as an operations assistant. Operations assistant again can somewhat relate to the same example as we spoke about for Zomato, or in fact you can have a chatbot where you can ask technical questions to the chatbot and the chatbot can give you technical answers on how to solve something as well, right? That can be operations assistant. And then you have phone assistant. Phone assistant, of course, every other assistant that we have been discussing right now either uses an assistant which is built for your phone, or it trickles off of that technology, right? So basically, yes, Siri, Google, Alexa, all these things are phone assistants. Again, I don't think I have to explain a lot about them, right? Perfect. Next, we have the entertainment assistant. Now, entertainment assistants are again super important in today's world. When you think about it, you can actually, especially I've heard that this is extremely popular in the world of football and basketball, where you can actually have conversations with respect to chatbots. You can ask questions about what it thinks about the match, its predictions, who'll score a goal, what will happen, at the end of the match, and you can do a lot of these things where you can not just talk to your chatbot, not just talk to your assistant, but get your assistant to predict the future for you, right? Now think about sport, think about predicting what will happen at the end of it even before it has begun. And I just gave you one example, right? Of course, you have ton of other assistants, in literally every other form of entertainment sector today. But at the end of the day, when we're discussing about some of these applications, I thought that it'll always add value to highlight that one super popular application that you might have, already known about, right? Perfect. Alright guys, now we've discussed a lot of these things about chatbots itself. Now we're going to get right into the heart of the concept now. We will have to take a look at the architecture of chatbots, as in what makes a chatbot what it is, right? Now that's a very important concept that we have to take a look at. Right guys, now whenever we're taking a look into understanding the architecture of chatbots, it must be very important that there are certain concepts, there are certain elements that builds a chatbot that is considered as common regardless of the type of chatbot, regardless the type of application that it is trying to solve as well. Right now, when we discuss the architecture of chatbots, I'm going to bring in the general image. I'm going to bring in a bird's eye view of this particular concept. Right now, if you dive right into the details of how they work, Siri works extremely differently when you compare it to how Google now works. Google works very differently of how Alexa works and all of that. So instead of just confusing you with all of these convoluted concepts, let's take a look at the entirety of governance of how a chatbot works. Right now, there's multiple different entities that the architecture should consist of. First of all, let's take it from the front end to the back end. Right, you have the chat window or the session. This is where you're communicating to the chatbot. Right, maybe you open up your phone and you just swipe up and Google now opens. That is your chat window. That is your session that just got created. Right, or you're talking to an Amazon chat related service, or you're talking to Zomato, you're talking to Swiggy and whatnot. So you have a user interface to basically talk to the chatbot. Right, that is the chat window. And as soon as a chatbot is active, it creates something called as an active session that it uses. Right, for example, if you're talking to a chatbot, there are certain chatbots where if you not talk to it for a while, it'll ask you if you're there, it'll try to ping you, it'll try to see if you are still around. Right, the Tesla's cars do this when it's on autopilot. The driver always has to have his hands on the steering wheel. If not, it's going to start giving you alarms. It's going to start asking questions saying, hey, you know what, are you awake, are you like sleeping or something like that. I just gave you a funny example, but yes, so having this kind of a interface where you're directly working with the chatbot, that's what the chat window or the session means. And there has to be an interface between. This is not the interface that we use. This is not the user interface. This is a bridge between the NLP model and the chat window. Now let's talk about the NLP model so we can talk about why we require this interface first of all. Right now, when we're talking about the NLP model, NLP stands for natural language processing. This is a model which is again built either using a neural network or machine learning algorithms in a way where it has the capability to first of all have certain points of data to use to basically give out answers. The second thing is it will also have the programming necessary to ensure that it can basically understand the question for which it has to pick the data and give you an answer. Right, that is all that fancy stuff, all the heart of it, all the brain of it, or you can in fact talk about a lot of different things. But you have to understand that without this particular entity, NLP model, this entire thing about chatbots will not be as sophisticated as we have today. Yes, you can still have chatbots without having a very fancy model. In fact, we're going to actually demonstrate that you do not require a super complex chatbot for whenever you're programming from scratch. So this is still required. At the end of the day, you can get away with it, but again, since we're discussing about everything, it becomes vital that we have it here, right, ladies and gentlemen? Okay. Now, the next thing that the NLP model, whenever you're expecting a model to train, what is it that it's required? You require data. Now, in the world of chatbots, we usually call data as corpus, as dictionary, or as there's a lot of names that we actually go on to provide to this. But whenever you hear those terms, corpus, dictionary, data, understand that there's a good chance it always means like it's basically a repository of information. Right? It is the data that the chatbot uses to give you answers upon. That's corpus. We're going to discuss corpus in detail in the next slide, right? And then you see application DB. Application DB talks about the database which hosts, first of all, your application. Second of all, it hosts details about how you will have to bridge a gap between the application to send it to the NLP model, and the NLP model eventually, now I'm talking about the interface, the NLP model eventually uses the interface to just push out those answers either in a textual form, in a voice form, or whatever it is, right? That is where the interface sort of comes into the picture, and then it just pushes the results out to the chat window. This is basically the entire working of a chatbot architecture, guys. Of course, in the NLP model itself, if you want to take a detailed look into it, you have a lot of different things of how the NLP model works. Now, I know that at this point of time, you might be like, okay, so we do not know how the NLP model works. Well, can you explain, right? Well, don't worry. That's exactly what we are going to do in the next section, where we're going to try to understand this process of what happens from corpus all the way to building your own, having a functioning chatbot that works as required, right? Perfect. So we're going to take a look at just that. Before we go on to do that, we have to check out how a chatbot works theoretically, right? Now, take a look at the screen right now. I have provided you with 7 very, very important steps, right? Now, this is a step-by-step discussion that we're going to have for this section where right from the first step, which is importing your corpus, all the way to the last step, which is one hot encoding, these are certain standard steps, standard methodologies of how we can use natural language processing. And of course, not just natural language processing, use Python, use the foundational concepts from the architecture of a chatbot to see how things work and eventually to build one ourselves, right? Okay, so what is step number 1 that you see on your screen right now? It says importing the corpus. Let's talk about importing the corpus for a second, right? Now, corpus, as I just mentioned, is the training data that is required for your chatbot to learn. Without a corpus, it's also called as a knowledge base, by the way. Without the knowledge base, without the corpus, without the data, without the dictionary, all of these are the same names, but without any of these, it becomes impossible for your chatbot to learn anything and to give you something useful in return, right? Now, if your chatbot does not know what an apple means, and if you continuously keep asking it questions about apple, do you think it can give you an answer? No, because it does not know. I mean, we are intelligent enough to research, right? Now, as soon as we want something, we know that, hey, just head to Google and type it in, learn something on your own, right? Computers sort of cannot do that. They can do the process of it, but when it comes to learning, they do it very differently compared to what we as humans do, right? So again, that is an important thing you have to consider. We require a corpus. We require the data compulsorily, without which a chatbot will not work. Why will it not work? Because it will not have any answers to the questions that we get asked, right? Now, if there is an examination and I've never attended college in my life, let's say, and I just go there with a textbook in my hand, and of course I've never opened that textbook, do you think I can clear the examination without any knowledge about the domain? Some of you might say maybe, you can do it probably, right? But then the majority of you can say no, it's not possible because you have not learned anything to, in fact, go on to showcase what you have learned. There again is the exact analogy of how the corpus works. Now, once you understand corpus, it means that at this moment of time, either we have textual data, voice data, we have in a database our data that's needed by the chatbot. But then, as always, data is a raw entity, data is a messy entity, and it takes a ton of efforts to pre-process your data and to keep it ready for the further stages. If you do not do it, I'll tell you at this moment of time that, your NLP model, your machine learning algorithm, whatever type of, intelligence you're trying to impart into your chatbot, that will not work if your data is not clean, if your data is not accurate, right? Because if you just provide inaccurate data, your chatbot will not understand that. It will not be able to discern it. It will just give you inaccurate answers back. And you might be thrown off by that, right? So that's an important thing. Pre-processing the data can be done in many ways. In fact, one very important way that we're going to be doing is text case handling, right? Now, the data that you might have, textual data, it can have a lot of sentences, it can have a lot of paragraphs. So if you just copy all the text and paste it somewhere, you'll realize that there's capitalization everywhere. There is lowercase text, lowercase characters in most of the spaces, but there are certain uppercase handling that's needed as well, right? So to make sure that we avoid any sort of misrepresentation or in fact even misinterpretation of these words, we just take all the data that we have in the corpus, basically these hundreds and hundreds of lines of sentences, and we either convert everything into lowercase or we convert everything into uppercase. And yes, Python will know which is being done, either uppercase or lowercase, so that later if everything is made into lowercase, when the chatbot replies, it will know to capitalize the first word for us, right? It's a super intelligent thing. We might think that, hey, is this all required? But then when you take a look at it, when you yourself talk to a chatbot like Zomato, Swiggy, Amazon, whatever it is, you will understand that it is as close to a human as it can get. So text case handling, without which to process a chatbot becomes extremely difficult. So this step is very much vital. Right now, after we convert all the text into either lowercase or uppercase or anything like that, this is just a sample on your screen with a process what we call as tokenization. Tokenization is when we have sentences, right? Now, I just said we have hundreds and hundreds of sentences in this particular document called corpus. Now, we have to break those sentences down into each individual word, because without that, you cannot just have your chatbot give you an entire sentence as it it is as an answer all the time, right? Especially if you're working on a chatbot and you have user experience in mind, you have to make sure that it will give you an answer that sort of answers this rather a specific question rather than just answering a random question out there, right? So look at this on your screen right now. Tokenization, as I just mentioned, yes, it is a process of how you can take a sentence, break those sentences into individual individual characters. You can see that it's written this is a blog. From this particular statement called this is a blog, it has been split into 4 separate entities. This is a blog, right? So this is the structured process that we use to convert sentences to individual collections of words, because if you have individual collections of words, they can be jumbled upon to make a sentence of its own, which again works pretty well in the English language, as we have seen with Python. And then you can have your chatbot give you fantastic answers based upon that, right? That is tokenization. Once we finish with tokenization, we come to another concept called as stemming. Stemming is fantastic. If you guys are fans of etymology, there's a good chance that you might have heard of this concept, right? Take a look at the chart on your screen right now. It just said original word, root word, and similar word. In the original word, we have a couple of words here: jump, jumped, jumps, jumping, right? We have 4 words, but all of these 4 words have one common root word. What are we talking about? Jumping, right? So jump is the common root word. So using this root word, you can actually form all these 4 words. Yes or no? Yes, right? So with stemming, all we're trying to do is, instead of just thinking about millions and millions of words, we just try to find the root word. Now, if you're a fan of etymology, there's a very good chance you know that this is an extremely powerful concept all in itself, right? So basically, knowing the word jump and knowing where all it can be converted into and used will help you a lot. Now, if you are a person who has ever prepared for competitive examinations, maybe like GRE or GMAT, where they have a literature section, there's a very good chance you might be using any of these techniques to make sure you have a high score there as well. Understanding the root word, so that every other word, maybe 10 or 20 other words that come below that root word, you're already done with just because you know one word, right? So stemming is this process. So where we try to find similarities between the words, we find the same root words, and we ensure that we can have this split up, and also teach the chatbot saying, hey, this is how it is. So you're basically making a chatbot not just more efficient at the same time, but also more intelligent as well. That's an important thing you guys have to know about. Perfect. Once we're done with stemming, we have one more fantastic concept called as BOW, or it's also called as bag of words. Now, it seems like a very funny concept, bag of words, but when you literally take a look at how it works, let me explain it first. Bag of words is literally like, let's just say I'm holding a couple of words right now, English dictionary words, and I just take it all and I just put it in a bag, right? That is literally bag of words. So with bag of words, what we are trying to have in concern is that we do have a lot of words. We do have words that can be used to answer a question. But at this moment of time, after stemming and after breaking it down into every single word, do you think order will matter? No, right? If I have, if you remember back when you were kids, you used to play a game called Scrabble or something like that, right? Scramble, Scrabble, something like that. So that game, again, if you take all those individual blocks, if you just put it in a bag and give it a nice shake, do you think the order of what is happening in the bag is important? No, we just want the words. The words are there in a bag right now. They might be random, they might be arranged, we don't know. But that's the entire magic of this, right? Now, for example, let's take a look at the same thing that we've broken it into single words, right? This is a blog that you see on your screen right now. Now, what happens for a machine learning algorithm, or what happens for a deep learning algorithm when it takes over this particular stage, is that it does not understand English words as it is. So these English words must be broken down into mathematical vectors for these particular algorithms to understand. That's the reason you see this is a blog is basically split into 4 words, and you see zeros and ones that are given there, right? So when when this statement has to be passed on to the machine learning algorithm, this is a blog. It basically takes this vector that you see here, 1 followed by 4, 3 zeros, and this entire vector and matrix, right? So this entire vector gets assigned there, and of course there's another process of how you stitch them together, where you'll be using something called as a dot operation, a matrix multiplication dot operation, where you'll be bringing 2 vectors together and sort of working with that as well. Again, the process of it working can get super complex, but the main advantage is when we try to implement this in Python, it still is pretty simple and easy to work with, right? But yes, this is generating bag of words. You have to understand, you're going to take a couple of words, you're going to find the root, you're going to stem it, you're going to separately cut it out into individual words, you're going to put all of them in a bag, give them a jumble, and right now you're going to assign numbers to make sure that, if there is a sentence, that sentence will have a vector that can be understood by the machine learning algorithm, right? Perfect. So this is bag of words. Now, after bag of words, there is one last process called as one hot encoding. One hot encoding is basically the process where we're taking all of these categorical variables and converting into a form where the machine learning algorithm just uses, as I just mentioned in this previous process, bag of words, right? So bag of words creates a vector, taking a vector and passing it to your machine learning algorithm for your machine learning algorithm to understand that, hey, this is this particular sentence, that is another sentence, right? So it needs to have a way of how it can discern sentences itself, discern words itself. Even though the order of words is not important, all the individual words are still important, right? So that is why we require this process of one hot encoding. Now, if you ever are curious about when you type something into a chatbot, right? Now, if you say hello, if the chatbot in the opposite side says hi to you, hello to you, how are you, what's up, or something like that, one hot encoding is the response is responsible for a lot of these responses that we actually get, because at the end of the day, your chatbot must be intelligent enough to go through the entire data, pick up something which is meaningful, and to find it as a reply to your to find it as a logical reply to your question. All of that works in the back end, basically, with this process called as one hot encoding in itself, right? Okay, guys, perfect. Now we've had a chance to take a look at the theoretical aspects of, we took a look at a lot of things to understand a ton about chatbots, right? So now is the right time. We'll actually go into, checking all these out practically. Now, guys, the goal of this particular demo is to make sure that you guys can understand that you can also create a chatbot in Python. You can build a chatbot from scratch without having to put a ton of effort. Now, at this moment of time, you might think, okay, if I need a decent enough chatbot, will it require hundreds of thousands of lines of code? If you're thinking on the lines of Siri, Alexa, and all of those things, maybe yes. But right now, we do not have to write hundreds of thousands of lines of code to build a simple chatbot, right? That is exactly what I am going to demonstrate with this particular demo. So let's basically open up Google Colab. Google Colab is nothing but a simple Python Jupyter notebook hosted on the Google Cloud platform, right? So let me just open up Chrome. Right, to access Google Colab, all you guys have to do is type Colab on Google, guys. Okay, as soon as you type Google Colab, it's basically called as collaboratory. It's a fantastic thing. I am a huge fan of Google Colab, and I use it all the time, regardless of if I'm at home or even before COVID when I was traveling, right? So it basically is a lifesaver. Alright, guys, so basically I've just loaded up the Google Colab platform out here. I've already written down all the pieces of code that's required, that's just been put on here, that's ready, so that we don't have to sit and type it out as we go together. But then let me explain how all of these work, right? So let me zoom in a little so that you guys can see all of this screen better. Now, whenever we're working with a chatbot or anything as such, the first most important step is to ensure that we can bring in all the libraries that we're going to be using for that particular use case, right? Now, in this case, we're going to require 4 important libraries. The first library we're going to require is NumPy. NumPy is basically used for numerical computations in Python, an extremely popular library for data science. And then we have NLTK. NLTK is a superb library for natural language processing in Python. It's one of the most amazing libraries that you get to work with if you're very serious about working with chatbots. And of course, we have 2 other libraries as well, string and random. String is to ensure that it can process and handle strings in Python, and random, basically, you're going to see why we require random as we go ahead as well, right? So as soon as I click that play button, as you saw, now I have imported NumPy, NLTK, string, and random with just a click of a single button. I can do this on my phone, I can do this on my iPad, I can do it wherever I have an internet connection and I can open a browser. How fantastic is this, right? Now, what's the next thing that we're gonna have to do? Now, the next thing is again another 4 or 5 lines of code. It's very simple. Let me explain. The first 2 lines of code, basically f equal to open, raw doc equal to f dot read read and dot lower. With these, all we're trying to do is we're trying to bring in our corpus, right? Our corpus is basically in the computer. I'm going to show you how we created the corpus also. So we're going to take a look at the corpus. We're going to make sure that our program has access to it. We're going to bring it, make sure our algorithm, basically our working environment has access to it. It can read it. Fine. That's first two lines, right? The next couple of lines, if you see line 3, 4, 5, what we're trying to do here is, first of all, you remember pre-processing where I told you either convert everything to lowercase or uppercase. Here that you can see with this particular dot lower function, I am taking the entire document, just bringing it down into its lowercase. Once it's been put into its lowercase, then we're going to be using this concept of a tokenizer that we discussed right now. In this case, you might see that we're using one particular tokenizer from the NLTK library called as the Punct tokenizer. Now, Punct tokenizer is basically a pre-trained tokenizer which has the complete capability to sort of, build a model around what's required and to give you an answer, right? So tokenizer as the process itself, you might be wondering why we are only using the Punct. Now, there are many other tokenizers in the picture that we have. We have the tweet tokenizer. We have something called as the regexp or the regular expression tokenizer that you can go on to use. But in this particular case, we're not trying to assess or we're not trying to import the corpus maybe from Twitter. If you were doing that, if you were maybe analyzing hundreds of thousands of tweets, you need to just copy all of them and bring it up, bring it together, right? That is when you'd be using something called as a tweet tokenizer. We're using the Punct because it's already pre-trained. It is very easy and fantastic to work with it, right? Okay, perfect. Now, the next couple of lines that you see is basically how we are converting all the documents that we have right now into a couple of sentences, and all of these sentences into lists of words later, right? So we're going to have two documents created. Basically, it's called as sent tokens and word tokens. Sent tokens means they are sentence tokens, and then we have word tokens where each individual element is a word. In sentence token, each element is basically a sentence, right? As simple as that. All we're trying to do is split it into sentences, splitting into words, and bringing it into our working environment. Now, as soon as I click run on this will not run. It will give me an error. Why? Because it does not have access to that particular corpus file. So it's in my desktop. Let me quickly open up the corpus file in my desktop. Now, while that is uploading, I'll tell you how I created the corpus, right? So basically, I just went to Google. I typed in, data science Wikipedia, and Wikipedia just gave me this particular page for data science, right? So all I did was I copied everything from first line here till the last line, and I put it in a text file, and I call that file chatbot.text. That's it, right? So this is literally everything that's copy pasted from our Wikipedia. Now, this is a very simple chatbot, but I just want to give you a demonstration to show what the corpus itself looks like, right? Now, let me run this again. It should run absolutely fine now. See, I told you, right? So it just didn't have access to it, and now that it has access to it, it can do it. Now what we'll do is we'll print a simple sentence token to see if the tokens are working fine, right? Now you can look at this. Data science is an interdisciplinary field that uses scientific methods, processes, all these. This is one sentence, right? So you can see below there is another sentence. Data science is related to data mining, machine learning, and big data. So with this piece of code, what I did was I printed two sentences out from the sentence tokens. Similarly, what I want to do is I want to print out the word tokens. Now I just want to print two words from the entire corpus that I have. Simple. I just printed the two words data and science. So basically what I'm trying to do to print this is to not showcase that you can print it. Of course you can print it. I'm just trying to verify if my data that we have actually created, let me just scroll up here. Here when we created this particular document where we are converting it into list of sentences and list of words, I want to see if it works or not. That's the reason why we have that, right? Now once that is done, the next step in the process is to basically pre-process the text, as I just mentioned, right? Now lemmatization, stemming, all of these processes are something that we took a look at, right? So this entire process of pre-processing basically works in this way. Either we're going to convert everything to lowercase or uppercase, and then the other thing what we're going to try to do is we want a normalized vector as a result of out of these. We can have a regular corpus data sent into it, and we want tokenized vectors. So we'll have to remove so many different things. Right? So first of all, there might be sentences which are not broken down into words. And if your sentences are broken down into words, what is happening to the punctuation marks? Did you guys think about that? Commas, full stops, and all of that, right? So you have to think about that as well. So to process all of these things, we'll be using a WordNet. WordNet is basically a dictionary that's already inbuilt and included with the NLTK library when we work with Python, right? So it makes this entire process of if it weren't for this particular these couple of functions that we're using, or if it weren't for WordNet, we would have to write a lot of code for this particular segment for pre-processing, right? Now, as soon as I click on it, my data is pre-processed. Next thing is the fun part. Now, this is a function where we are trying to build a greeting function. Now, a greeting function is very simple. What does it mean when I say greeting? When I say hello to my to my chatbot, I want it to give me a reply. But then I will not just say hello. I can say so many different things. I can say hi. I can say sup. Sup is basically the millennial short form for WhatsApp, right? I can say what's up. I can say hey. I can say a ton of different things there, and you can understand that these are the inputs that I'm going to be giving it, right? It doesn't mean that I have to give it all. I can give any one of these inputs and it'll understand that, hey, this person is greeting me. And when I input either hi, hello, greeting, sup, what's up, and hey, it will give me a response back saying, hey, hi, nods, hi there, hello, I'm glad you're talking to me, right? So it'll give you any one of these responses. This is why we require the random function at the start. You remember? Let me scroll up. Import random. Why we require that library is when I myself give it an input, it will basically give me a random output. Look at this word, random.choice, right? So it'll just try to find my response, and as soon as it finds my greeting response, it's gonna my greeting input, it's gonna give me a greeting response, right? As soon as I run this, now it knows how to greet people, right? And what have we done? We've used 4, 5, 6, 7, 8, maybe 20, 25 lines of code, and we've come to a point where our chatbot can already say hi and bye to us, right? Now the next thing that we're gonna have to do is get some responses to the questions that we ask. To do that, we basically will be using two concepts called as the TF-IDF vectorization and something called as cosine similarity. Now, to quickly explain what this means without going into a lot of detail, TF-IDF basically stands for term frequency and inverse document frequency. Term frequency, as you might guess right now, talks about how many times all the words, each individual word is repeated in your corpus, right? That's term frequency, the frequency of occurrence of words. And then you have the IDF, the inverse document frequency. This is an absolutely fantastic metric because, see, to find term frequency is very simple. Just find out all the words, list them out, see how many times they're repeated, add them. It's a 10 lines of code, and you can do it simple, right? But the IDF part of it is very interesting because here we are not just trying to pick up words and say, hey, this is a word that's repeated 10 times, but here I'm trying to attach a sentence of attach a component of how rare the word is. That is why we require the inverse document frequency. How rare is the occurrence of the word in the corpus, right? Now there are so many words which can occur so many times. For example, if the word is data science, or if it is data, let me search for this. See, there is 120 times the word data has been reused, but it is not very rare or something like that, right? It's used 120 times. But if I try another word which is not so popular, like the word explorer, it has been used, but it has only been used once, so it is super rare. The IDF picks this up and it realizes that, hey, okay, these words are rare, these words are repeated so many times, and all of that, right? Cosine functionality does that. Once we have bag of words, once we have everything ready in terms of ones and zeros, it takes all of that and gives us a normalized output. Now, if you do not follow the technicalities of it, absolutely do not worry anything. So basically what we're trying to do is to find the number of times a word is repeated in our document to ensure that, we can have and map the rarity of it. And the third thing is we can have the normalized vectors so that whatever we are doing right now, our machine can understand that, right? That is the simple aspect of it. Now, the next process that we're going to do on the same lines of response generation is to make sure that we provide certain data to it and it gives us an answer. We've already provided the corpus, so now it has to give us the particular answer when you're building the entire neural network and giving us an answer out there, right? But then you also have to think about certain situations where you try to type in something your chatbot doesn't understand, so you have to also write. So if TF-IDF is 0, it means that your chatbot does not understand what's written on your screen or whatever you just gave it as an input. So there it will basically tell you, hey, I'm sorry, I don't understand whatever you are saying, right? So basically it can greet right now, and the next thing is it can know what it can understand and what it can not understand as well, right? So let me zoom out a little for the next one, and basically for the last piece of code, right? So we are already at the last piece of code and we are not writing hundreds of lines of code here, right? Okay, perfect. Now this is where we're going to be defining the start and end of a conversation. The start of the conversation is basically a for loop, where the bot will continuously keep waiting without any sort of timeout. It'll forever wait if I do not talk to it, right? But then there you can change. Maybe if the user has not responded for 30 seconds, you can actually close the bot. You can do a ton of these things. This is the most basic bot, just to showcase the power of how you guys can go on to use Python to get to this point as the goal here, right? So let me actually in fact run this. Here all we're trying to do is, as soon as you're trying to, the user says hi, it'll start talking to you back. If the user says bye, it's going to quit, and eventually it's going to give us all the responses in between that makes our chatbot intelligent, right? Let me run this piece of code. Now the piece of code is run. Let me just read what it says. It says, my name is Stark, let's have a conversation. Also, if you want to exit anytime, just type bye. Well, let's just see if the exit thing works, right? I'll just type in bye. As soon as I typed bye, it says goodbye, take care, and a small heart. That part of it, the code is right here, right? So when I said bye, it understands that this person wants to leave. Let me run it again. This time, you know what I'm going to say? I'm going to say hello. So when I say hello, it nods, as in it's shaking its head. It wants to listen, right? If I say hi, now it'll give me another reply, hey. So it basically is randomizing all of these inputs. Whenever I say hello, hi, greeting, what's up, and I say any of these things, it's basically giving us an output for this part of it, right? Okay, now hi worked, hello worked, and all of that worked. Now since we're talking about data science, let's try to see if we can find out something about the corpus itself. So when we want to try to ask what is data science, right now the model is not, chatbot is not that intelligent enough where it'll understand all the questions directly. But if I wanted to print me, let's say the foundations of the data science, let's see if it can print something like that using the corpus, right? See, it found so many things when I said the word foundations. It says data science is an interdisciplinary field focused on extracting knowledge from data sets, which is typically large data sets, applying knowledge and deriving actionable insights to solve a wide range of problems or applications. Look at that. I just said I want the foundations of data science, and it basically gave me a one-line answer to what it understands as an answer to what data science is, right? How fantastic is that? Maybe I want to ask another thing. It says impact at third point here. I want to say impact of data science. Enter. And as soon as I have an impact, look, it gave me one more fantastic sentence. Of course, there are certain warnings which says your stop words are inconsistent because we do not have that big of a corpus to train. It says, as big data continues to have a major impact on the world, data science does as well due to the close relationship between the two. So it's telling me that, hey, big data has a huge impact in the world. Data science also has a huge impact into the world just because these two are tied very close to each other. I asked it saying, what's the impact of data science, right? And it gave me another answer. Now what happens if I just type data science? Now, if I just type data science, it says that, hey, it just picked up one random sentence. Now, this is where the bot might not give you as accurate answers as you might think. But then, hey, this is a very, very, very simple bot. It says, however, data science is different from computer science and information science. So basically, this is the line it first picked up from its corpus, and it's just giving us that particular answers, right? Now, maybe if I want to find out techniques in data science, right? Let me just type for techniques. And look, it found something in this particular domain called as technologies and techniques. They said there are varieties of different technologies and techniques that are used for data science, which depend on the application itself. Okay, this is a very good answer, right? So apart from one or two answers, you can see that once I quizzed it with 5-6 questions, it answers all of these things. And ladies and gentlemen, okay, let me just say bye to the chatbot. Let's close it first. Let me say bye to it, and it says goodbye, take care with a heart. Okay, cool. Now let me actually go on to clear all the outputs first of all, and let me zoom out to show you how much of code that we have written, right? 4 lines, another couple of 6 lines, 10, 11, 12, 18, 24, 25, 26, 36, 46. All of this is less than 60 lines of code, guys. 60 or maximum 70 lines of code, and all of these are very, very simple pieces of code, right? Take a look at that. we have not done much. I'm just scrolling through it. If you can look at the scroller on your right, and all of this is an entire chatbot on its own. Of course, this chatbot is not as intelligent as Google, it is not intelligent as Siri, but at the end of the day, this is a chatbot that is going to give you all the important answers that you require for your questions. And we never put in a lot of effort to go on to showcase this, right? So yes, at this moment of time, the goal of the demo again is to not run through each and every line of syntax to tell you why this is called lem tokens, why is it not called anything else. No, my point here is to showcase that you can build a chatbot in Python without having to put much effort, and I think that was showcased beautifully with this particular demo, right? Perfect. Alright guys, superb. That brings us to the end of this fantastic session where we built our own chatbot using Python, right? To quickly summarize everything that we have learned, we started out by taking an introduction to chatbots to understand what they are, how they work, the history of chatbots, the varieties of types of chatbots that we have in application, and types of chatbots that we will require while building chatbots as well. After which we walked through of how we can take a look at some of the top applications that we have in today's world for chatbots. And once we understood these applications, and once we were excited to really understand the architecture of chatbots, that is exactly what we did. We discussed the architecture, we discussed the components, followed by which we also took a look at how a chatbot works in superb amount of detail in a step-by-step process, right? Once we finish the process of how a chatbot works, we also ensure that we are going to combine all of these things that we learned theoretically and demonstrate all of that practically in Python by creating a simple chatbot. So I hope that everything that we've covered in the agenda for this particular video is clear for all of you all. If you have any questions, any comments, or any suggestion on this, please make sure to head down to the comment section and put them down there. We'll be more than happy to answer your questions, and of course take on the conversation there and continue there as well, right? Alright guys, thank you so much for watching this particular video. Have a nice day ahead, and make sure you guys are subscribed to the Great Learning YouTube channel for more content such as this. My name is Anirudh, and I'll see you in the next one.
I want to introduce you to Great Learning Academy. This is a free initiative by Great Learning where you can have access to over 200 plus courses with 1000 plus hours of free content on all of the trending high demand domains absolutely free. Register now to complete the course and get your free certificate of completion as well. Check out the link in the description box of the video below for more details. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell. This is done to make sure you do not miss out on any of the new updates or video releases from Great Learning. And of course, guys, if you enjoy this video, show us some love and do like this video. Knowledge increases by sharing, right? So make sure you share this video with your friends, colleague, and everyone who can make use of it. And at the end of it, make sure to comment on the video if you have any queries or any suggestions, and I'll be more than happy to respond to all of your comments.